So what are beats and how are they produced? Consider any type of a wave, be it a water wave, a sound wave, even a compression wave. When two waves simultaneously pass the same region of space, they will interfere with one another. Here I have two speakers, two sound speakers, producing the same frequency to illustrate an example. You see the sound waves moving outward, just like dropping a pebble into water, and you see the ripples of the wave propagating away from the source of the disturbance. So here's one speaker, and here's the other speaker. Both speakers are producing the same frequency, and when those waves collide, what happens is the crests add up constructively, and the troughs add up constructively. But where a trough meets a crest, they will end up canceling each other out. So here I have all the crests illustrated, and the troughs would be considered the part in the middle. So what happens is when the crests collide, you end up getting constructive interference. And in the case of a sound wave exhibiting constructive interference, you would hear the sound louder because those two sources add up together. Now, if you have a crest, illustrated by the line, interacting with a trough, illustrated just by the empty space, what happens is the crest cancels out the trough, and you don't hear anything at that position. So imagine that this was a concert hall, and the speakers are facing towards you, and you're listening. Well, depending where you're seated in a concert hall, you will hear sounds louder than others. Now, if one of these two speakers was removed, and you're in the concert hall, so we remove that speaker, then that wave, that sound wave is not being produced. And if you were, unfortunately, sitting in a position where there was no sound, all of a sudden you would hear some sound. And in those positions where you were hearing the sound louder because of constructive interference, now you would just hear the sound coming from one of the speakers. Now what we just talked about is just basically interference. It doesn't illustrate what a sound beat is. Now we're going to explore that. Sound beats are due to interference, but it's for a particular reason. So if the frequency of the two sounds differ, the result of the interference is it's a lot more complex, and actually it's very interesting. So here I've roughly illustrated two waves, and because it's just a hand-drawn sketch, I'm going to emphasize that the green wave length is larger than the red wavelength, and you can see that the green is spread out more than the red. So they're slightly different. So when these two add up, when they interfere, if you were to redraw this, that's our phone in the background, then what will happen is you'll end up getting this kind of a pattern. I'm just going to let that go, and we'll just continue. So what happens is when these two waves interfere, the wavelength is all the same, or the frequency is all the same, due to constructive and destructive interference. Now the interesting thing is that the amplitude varies, and it varies with a pattern. So it goes up and down, and you see that at one point you have a high volume, and at another point you have a low volume. And what the beat frequency is you end up getting a high. Okay, so the message machine stopped, and now it can continue. So you have a high volume changing into a low volume. So it goes high, low, high, low, high, low, and that's the beat that we hear. And it's kind of like a vibration, so it's almost an eerie sounding sound. It's a continuous tone, same frequency, but the amplitude goes up then down, and we call that a beat frequency. I'm going to show you a computer-generated illustration, which will be far better. And in class, I'll also show you, produce the sound and show you the computer-generated picture in real time. but just so you have something for your notes. What I've done here is I've enveloped the beat frequency just to show you that that red line refers to the actual beat that we hear. And the beat is distinguishable. You can actually hear the beat. It may go, the beat frequency may go something like that. So the beat the beat refers to the amplitude going up and down. As I said, the wavelength is constant, and the wavelength is a combination of these two waves. So beat frequency is the difference between the two frequencies. Very easy to calculate. All you need is to know the difference between the two, and it's just the absolute value. So F2 minus F1 or F1 minus F2. Now, where can we use the beat frequency, or where do we find beat frequencies? In tuning a piano or a guitar, we can use a technique of beat frequencies. And what the tuner does is, I don't play guitar, so let's pick the G string. So you pluck the G string and you hear the G. And you perhaps tune that G string against a piano key or a harmonica or a tuning fork, and then I definitely know that that's a G. What I could do with adjacent strings on the guitar is I can move my finger along the adjacent string until I produce the G sound by shortening the length of the adjacent string. So I now have the full length regular G string on the guitar, and then I have the shortened adjacent string also supposed to play a G. And I tune the guitar to match, to have those two strings match one another. Now, if I'm slightly off, I'm going to hear a beat. That's how guitars can be tuned, by adjusting until that beat goes away. When the beat goes away, there is no difference between the frequencies. So that adjacent string, which has been shortened by using my finger to shorten it, that frequency matches the G string, and then I have in turn tuned that second string, and I can continue that with all the strings on the guitar. A piano tuner does the same thing. Piano tuner will tune, say, the first key using a tuning fork, and then adjacent keys, he'll play those keys, 2 keys at a time, and you'll listen and see, do those two keys match one another? And if they're slightly off, then you'll hear that kind of a buzzing beat sound. And then they'll tighten or loosen up that adjacent string in the piano. Another place that we see beat frequencies are alarm sounds. You may be familiar with our local area on the television, on the radio. They have they test the emergency system where, in case there's a disaster or something like that, what they'll do is they will start the announcement with a sound, and that'll capture your attention, and then they will proceed with the announcement. That sound is meant to be annoying. It's meant to capture your attention. And the way they produce that is they take 2 frequencies that are very close together and they play those simultaneously. Sirens, alarm system, your smoke alarm also produces 2 simultaneous frequencies that interfere, producing that beat frequency.